Good. We continue with domain modeling. So first, domain characterization. Second process, sub-process of domain analysis is domain modeling. Conceptually, this is the case actually. So we given a problem, a system that we need to develop, we can identify some domains. And domain includes set of knowledge sources. We evaluate these knowledge sources based on abstraction quality, objectivity, relevance. We select these knowledge sources, and then these knowledge sources includes set of domain concepts. Okay? Domain knowledge sources, and this is actually what we care about. We need stable solution domain concepts. This is the required domain. We select the knowledge sources, and the concepts are actually in these knowledge sources. For us, well, it's a kind of raw data. We have still to structure these, classify these, and model these. Then we get the domain model. So how do we do that? The process for that is commonality analysis. It's quite easy actually. So you have a number of knowledge sources. Like here, this is domain. It's in abstract sense. These are the knowledge sources. You scan these knowledge sources and look at the common concepts. For example, this could be a textbook, domain expert textbook, etc. For example, what is common here? This rectangle, right? It is common in each knowledge source. So we scan these, and then we get the commonality, the common concepts of these knowledge sources. So you scan, for example, in the monitoring systems, different knowledge sources, and it appears that the concept sensor appears in each of these knowledge sources. And you say, oh, okay, this is an essential concept because it's common in all these knowledge sources. The knowledge source which we have selected based on abstraction quality, so the relevant and objective knowledge sources. So to develop a monitoring system, I need to have a concept called sensor. Okay? So then you hope to identify in that way, so the commonality analysis, you will derive the common concepts which are important in that domain. Let's give a more informal example to grasp the idea further. This is about Orchid. I guess most of you have heard about this Orchid, but if I say what is an orchid, what's that? What's an orchid? Flower. Yeah, that's the first thing that we know. What else? Insurance system is a system to insure, right? It's similar. But that's also, orchid is a flower, we know. Any other ideas what it is? And probably you have seen dozens, hundreds of orchids. Maybe, I don't know. So orchid, so, sorry? Livings?
Very water. It needs more water than other flowers.
That's a property. That's a property. I don't know whether it needs more water, but so if you look at the commonality analysis, what does it mean? Commonality analysis means, so I would like to understand the domain of orchids. For that, what should I do? There's a domain of orchids. I define important knowledge sources. Okay. Like from the botanic experts, they have written some textbooks on that, and then I get, based on these commonality analysis, it appears that an orchid can be modeled like that. An orchid is indeed a flower. Surprise, surprise, right? That's what we knew. But it also says an orchid has 3 sepals. These are the outer floral walls, and 3 petals, inner floral walls. All the sepals and the 2 lateral petals are usually similar to one another in color and shape. But the remaining petal is always distinct from them, is called labellum or lip. It is usually larger and different in color and shape, often being lobed or cupped. This is labellum. And what are the petals? I think these are the inners and this is the sepals, or vice versa. You see, this is from the domain experts. If we take any orchid, you can say it should have 3 petals, 3 sepals, and 1 labellum. That's the model, a canonical model of an orchid. It's an informal example, but this is the process how we do. This is the same for defining also domain model for canonical commonality analysis for insurance systems, driver monitoring systems, information management systems, transaction systems, real-time systems, command control systems, any domain. Okay, you take the knowledge sources which are relevant and objective, you do a commonality analysis. And very often you identify new concepts which were not in the requirement specification. And these concepts are just stable. They are defined by experts in that domain. So we have to model the domain. Model the domain, so that's the domain model. Domain model is an artifact in the architecture design process. Domain model is an explicit representation of common and variable properties of the systems in that domain. Just you formalize, you represent in some way. Okay? Like we did requirements analysis, we have requirements model or requirements specification. Here we don't look at the requirements but the domain, and we try to define the domain model. How do we do this? There are different domain modeling techniques. First of all, domain definition, domain lexicon or glossary, conceptual models, and future models. Domain definition is just textual description in natural language. Describes the scope of the domain. It explains what is in, what is out of this domain. It provides examples and counterexamples. Domain lexicon provides description of the basic terms, just like a dictionary, a lexicon, glossary, you define the glossary. Conceptual models describes concepts, so you define the concepts. Conceptual model defines the concepts, for example, as object-oriented diagrams, ER diagrams, or any suitable modeling techniques to represent the concepts and the relations among these concepts. The fourth one is also quite popular. Future models is used as a graph-based approach. A tree, it's actually a tree, describes common and variant properties of the concepts. I will explain this. The first one, domain definition. Just a text, chapter or section in your architecture design document, or domain is about this and that and that. Okay? You provide some references, like here, driver monitoring system is a control feedback system, etc., etc. Examples are this. We will not consider that one. So it's just a textual definition of your domain. This is independent of requirements, of course. We are now discussing the domain. You define also the next one is the domain lexicon or glossary. You identify the key concepts. The key concepts have been derived after a commonality analysis. The key common concepts in that domain. Monitor, for example, entity that monitors the driver and the engine performance. Sensor. We did the commonality analysis to all these knowledge sources, and it appeared that sensor is an important concept. We provide it in the glossary. We provide a description, entity that observes the controlled entity. Control data, data which represents the goal parameters. Feedback, reaction given to the driver, display, etc. So the result of the commonality analysis is a set of concepts, and these concepts you can also define in the glossary. So that's the second one. Conceptual model. In the related knowledge sources, you have identified the concepts, but also you can get knowledge about the relations. And based on that, you can define the structure, the conceptual structure. For example, this is the driver monitoring system. It's a very high-level conceptual model. We have driver monitor. So you have a driver concept. It's a kind of component, element. An engine. The driver is sensed by the sensor. It's observed by the driver sensor. And you have an engine sensor. There's a central controller which reads the data from the sensors. The controller can be configured by the control settings concept, and output is given to the display. Okay, conceptual model. Again, we said we should not define in an informal way, so we define, even if it's conceptual, should be quite as precise as possible. So this is concept, this is association. You can also use here generalization, part of, etc., any relation. So it defines the conceptual structure, and this gets very close to the architecture that we are going to build later on. Okay? Domain definition, glossary, conceptual model, conceptual structure. The last one, but definitely not the least one, is the feature-oriented domain modeling. A feature model. In the feature model, you can represent both the common and the variable properties or features of the products, and also the dependencies between these features. Feature diagram is in essence a tree consisting of a set of nodes. The nodes and edges. The nodes are concepts or feature or properties of concepts. And what's a feature? There are actually two definitions. Either it's a distinctive property of a concept in domain model, or user visible characteristic of a system. Okay. Like a mobile phone, that's a concept. A feature could be whether it has Bluetooth or not. Right? Or display, red, green, or that was the feedback display, right? Etc. We will see some examples. A feature diagram is a tree consisting of nodes. At the top, you define the concept, monitoring system, insurance system, and you can have features. You can have mandatory features, which defines that every application that you are going to develop should have, that the system should have these features. You represent like this as a closed bullet. Optional features, so open bullet. Alternative features, so optional is you can have the property or not, the feature. Alternative, you can select one of it then, not both, or you could have multiple alternative features. This is the way how you represent. And finally, OR features. Usually in the literature you see there is 3 kinds, and very often also this one, OR features, which says each application must have one of or multiple. That is, so this is more the XOR logic, select one of them. Here, either this or that or that or multiple. It's OR. Okay? Example, insurance system. We identified the domain of insurance system. We talked to domain experts. We analyzed the knowledge sources. We did commonality analysis. And then we defined the concepts, definitions, and this is also another domain model, a feature diagram, where we represent the domain of insurance systems. An insurance product consists of 6 mandatory features, that is, insured object has a coverage, a payment, conditions, premium, payee. These are mandatory. So we didn't put here the closed bullets. It's by default, so you can do. It's possible. An insured object has 4 alternative features. That is, you can insure either a corporation, a realty, movable property, or person. You select one of these. Okay, not 2 or 3, just one. This one is optional, so payment can be either service or amount. You select one of it. You get either a service back or you get your money. And you can have optionally your own risk or not. So it's in the system that you are going to develop. This is just the domain model. You have not developed the system yet. Coverage. It's an OR feature. What did we say? You can select one or more of these. It's illness, life, unemployment, damage, or loss. Here again it's alternative. OR feature, a payee can be person or corporation, or person and corporation. Conditions is mandatory feature, should be acceptance and exception. See? By doing this, we have represented the complete domain of insurance systems, independent of the requirements, actually. If you look at this, you will see that not all compositions are possible. For that, compositions means like if we select some feature here, it might have a constraint on other features. There are actually 2 basic features, 2 basic composition constraints, mutex or requires. Mutex means that if you select one feature, you cannot select another feature. Requires, on the other hand, means if you select some feature, you should select another feature, a given feature. If you look at this example, insurance product, can you give an example of requires and mutex composition relation, a requires relation, for example? Or maybe easier, a mutex first. Mutual exclusion. I select one feature, person. Insured object, I select person. It is mutually exclusive with which feature, can you say? Insured object. No, it's not mutually exclusive. So you can insure a person, I can insure myself, and I can pay myself. Right? It's not mutually exclusive. There's no constraint there.
Maybe if we select insured object as corporation,
Yes.
we cannot select coverage as illness.
Right. Doesn't make sense. Your insured object is corporation, and your coverage is illness. So you have to. This is the theoretically possible, but in practice they are not all possible. If you select corporation, you cannot select illness. That's one example. Required, can you define a required? That's an example of mutual exclusion. What's a required? So the required, so these constraints can be defined based on two criteria. One is from the domain. As example, if you select corporation, you cannot select illness. But the second one is also from the requirements perspective. Okay? You can put some constraints to reduce the space. Can you give some examples? One example for required. So what is damage? Coverage is damage, yes, and then if you select this one, then it requires this. Oh, very good. If you select movable property, then you should select damage or loss. These are some constraints. If your object, person, this person is mutually exclusive with coverage damage. Damage is for cars and houses, but the person can only get ill. If coverage loss requires that the insured object is a movable property. If coverage is illness, it's mutually exclusive with corporation. That was the example. If the insured object corporation is selected, it requires that the payee is also a corporation. Okay, so you are not allowed to pay yourself, but the corporation should. Okay, it's quite easy, right? So once we have this, so we have defined actually the set of possible insurance systems. How many insurance systems can you derive from this? Anybody mathematical genius? Yeah. Can guess around given this. Almost 3,000 alternatives, right? This is so the optional is times 2, right? This is just 1. You can select that or that, so it's also times 2. This is times 3. You can select this, that, or both. This is times whatever and times it. Okay, then you get around 3,000. Alternative health insurance that covers illness with your own risk and direct premium. See, so what we then will do, so we define the domain model. Then we will look at the stakeholders, constraint. What do you want to build? So if the stakeholder says, I'm only interested in insuring persons, then the set of alternatives will be reduced, of course. Okay, so it helps to guide the system development. So let's do a short exercise then. Define a feature diagram for the driver monitoring system, including the following features. Display can be either red, green or multifunctional. Control data can be entered directly by the user and or downloaded remote from a network. Driver performance must be monitored based on physiological characteristics and driving behavior. Physiological characteristics include eye movements, head movements, and optionally heart rate. Driving behavior includes tracking, steering movements, brake maneuvers, and transmission maneuvers. Okay, just take a paper and try to define the feature diagram. And then the features. Catch. Okay, we get an example. So maybe you can, okay, driver monitoring, right? Good, has display. Very good. They are mandatory features. Good. Then display can be either red, green, or multifunctional. So it's alternative, or what could also be, it's not XOR, but could also be OR. But go ahead, it's okay.
We shouldn't have to choose one of them. I think it should be must XOR. Because it says can be either red, green, or multifunctional.
Yeah, then it's XOR. If you interpret like that, it's okay. It's okay. Control data can be entered directly by the user and or downloaded from a network. It's alternative, right? Driver performance must be monitored based on physiological characteristic and driving behavior. Yeah, okay. Physiological characteristics include eye movements, head movements, and optionally heart rate. Driving behavior includes tracking, steering movements, brake maneuvers, and transmission maneuvers. Heart rate is optional. Optional.
Other option.
Good. Thank you very much. It's okay? Easy, right? So how many alternatives can we derive here? This is 2 times 2 times 2. This is not alternative. Well, alternative model. No, it's mandatory. So you have to say, because you put here mandatory, there's only one choice in this branch. But there are 2 choices here in this branch. So that's 2. Here, 1. 2 times 2 times 2, 8. So so this is used in both in architecture design, but in particular product line engineering, where you have to specify the features, the commonalities and variabilities of all the products that you are going to develop. But also in software architecture design, it can help to provide a view on the domain, and then you can decide. So you discuss again later on, so iteratively, what to build and what not to build. Okay, quite useful. Thanks, very nice job. Summary. Requirements do not provide a suitable basis for deriving architectural abstractions. Requirements, architectural requirements, as we have seen, is very important process. You should identify the stakeholders and derive the stakeholder concerns. If you would miss one of these concerns, you would not have the right architectural boundaries. So it is important, but it's very difficult to derive the architecture from the requirements. So what did we say? So instead, after the requirements, don't try to define the architecture directly, but first try to understand the domain of the architecture, of the system that you are going to develop. Okay? So the issue here is that architectural abstractions, the elements, should be derived from the solution domains. What's a domain? It's just an area of knowledge. An analyzing domain is called domain analysis process. It's a systematic process to capture and represent that knowledge to support software development. Domain analysis consists of 2 basic processes: domain scoping, where you identify the domains and the knowledge sources. Okay. The knowledge sources are evaluated with respect to abstraction quality, objectivity, relevance. Once we have the set of reliable knowledge sources, we analyze these knowledge sources and try to get the concepts, the important concepts. The analysis is based on commonality analysis, we just compare, and variability analysis. To represent the domain, that process is called domain modeling. We can use different techniques. We can define in textual way. Okay, we can define a glossary. We can define a conceptual model. Conceptual model, you can use object-oriented diagram, ER diagrams, or any notation. So notation that can help you to define the concepts. And very important one is also future modeling. Okay. So that's it. That's the domain analysis process so far. Any questions? Okay, let's break at this moment then for 10 minutes, and then we will continue with the synthesis-based architecture design process.